Hello everyone, this is Zealand's class and today we are going to talk about integration of 1 over x squared plus a squared. Well, firstly, we should revise some skills that we learned before, so such as integration is the reverse process of differentiation. And that is what we learned last lesson, which is the differentiation of inverse tangent x, which is inverse tangent x is equal to the differentiation of inverse tangent x is equal to 1 over x squared plus 1. So that is what we learned. And according to this rule, which is integration is the reverse process of differentiation, we can know that the integration of 1 over x squared plus 1 dx is equal to inverse tangent x plus c. So that is our rule. And so now let's extend this into 1 over x squared plus a squared. So let's try to differentiate 1 over x squared plus a squared dx. Now what we need to use is we need to use our chain rule again. So now firstly for this, because we have the rule here, so it's x squared plus 1, which means we should try to make this a into a number 1. So what should we do? Well, we can just divide it by a squared on both sides, and let's take the 1 over a squared out. So we have 1 over a squared times 1 over x over a squared plus 1. So we have this. And why do we change to this? Because if we assume that y is equal to x over a, then this is equal to 1 over a squared times y squared plus, so 1 over y squared plus 1. And here this part is a constant. So when you're doing differentiation, integration, you don't need to care about this. So you only need to deal with that. And it will be very easy because it's the same as here, but we only need another few steps. So now we have this equals to that, and now there's a problem. So like here we have dx, but here we have x over a, and if we set x over a equals y, so then we need to have here, so we need to change dx into dy, otherwise we can't do the differentiation. So now let's change. So we have x over a equals y, then this is a function, right? So we can do differentiation of this function, and we will get dy over dx, which is equal to 1 over a. And dy over dx is equal to 1 over a, so we know that dx is equal to a dy, so that is what we get. Why do we need that? Because here you see there's a dx here, and we want dy here, so which means we want to change dx into with the form of dy. So now we can just write this into a dy. And now we changed the function from here to here, which is 1 over a squared, and then integration of 1 over y squared plus 1 times a times dy. So that is what we get. And now here is y, and here is y here, so we can do our integration now. And what is our integration? Our integration is equal to inverse tangent x plus c. And we know that here the a is constant. What does this mean? This means that we can bring this a out. So which means we can have a squared 1 over a squared times a times tangent inverse tangent y plus c. And we will get 1 over a times tangent inverse tangent y plus c, and because of y equals x over a that we set here, so we can change this y into x over a, and that is our answer. So we get integration of 1 over x squared plus a squared dx equals to 1 over a inverse tangent x over a plus c. and we can use this formula. But by applying this formula, it's good. It's much better to prove this by yourself again, because if you didn't memorize the whole thing or something, then you will get wrong in the questions. So it's good to like this. So like to prove this by yourself. Okay, so now let's try a question. For example, this question. Well, I'm just going to apply the formula, but I hope you can solve this from the beginning, just like I did here. So the all proving stuff, you can solve it by yourself. So now I'm going to tell you how to apply this formula. So now we can see that there are numbers here, which is 3 and 0. And this means that this is a definite integration. So we need to, firstly we need to find the indefinite integration first. So now we have y1 over x squared plus a squared as our formula. And we know that 9 is equal to 3 squared. So we can change this into x squared plus 3 squared. So 1 over x squared plus 3 squared dx. And now let's apply the formula, which is 1 over 3 times inverse tangent x over 3. Then we don't need to then do bracket 3 and 0. So we don't need to write c here, because c will cancel out. So if you have c here, then it will eventually cancel out. So yeah, so you don't need to worry about c, because c is a constant here. And now, so we can just sub the value in. So we have a third times inverse tangent 1 minus a third tangent inverse tangent 0. And that is, so let's use our calculator now. So we have 1 over 3 times inverse tangent 1 minus 1 over 3 inverse tangent 0, which is equal to 15. So we have here as 15, and that is our answer for this question. And now let's do this question, which is a bit more complicated. And this one is so integration of 1 over 4x squared plus 3 dx. Now, because our formula, so like here, the formula is x squared plus a squared. Here it's only x squared. However, what we have here is 4x squared. So what should we do? Well, we should get rid of this 4. And this means that we times the quarter at the front. So we'll have a quarter times x squared plus 3 over 4. So 1 over x squared plus 3 over 4 dx. And so which means that we change this into the formula of the form in our formula. So now let's change this into something squared, which is a quarter times the integration of 1 over x squared plus square root 3 over 2 bracket squared dx. And now we can do this, which is a quarter times, well, here we have square root 3 over 2 times inverse tangent x over square root 3 over 2 plus c. And that is our answer, but we just need to simplify this. So we have square root 3 over 8 times inverse tangent x times square root 3, so 2 over square root 3 plus c. And And now, so we have a square root 3 over 8 times inverse tangent 3. So let's rationalize this, and we will have 2 square root 3x plus c, and that is our answer. And so this is the whole part of the integration of this function, 1 over x squared plus a squared. So why do we need to learn this? Well, because it's very similar to the ln one, because 1 over x is changing into ln x. And for this equation, because there's an a here, so we can't change into ln, and we need to apply the inverse tangent. And that is all for today. And if you want some more details, you can go to the channel by Daniel Dallas. And thank you.